Hello class, this is a video tutorial for directional fields or slope fields. In this video, we'll be looking at derivatives with more than one variable. Since learning the topic on differential equations, we now know of derivatives that require x and or y to determine the gradient of a function or a relation, such as these that we've seen before. Notice how with this, we have a variable of y, this and these three have variables of x and y. Having seen these examples of differential equations with one variable, the same principle that we've seen in the previous videos can be applied if multiple variables are present. So let's get straight to an example with this one here. Alright, so let's get straight to it. For this, we simply use substitution once again. So substituting this -3 here and y here. So this becomes negative of -3 minus 3. So that will give us 0. So negative of -3, substituting this, minus 2, that gives us 1. Negative of -3 minus 1, that gives us 2. And I hope already you can see a pattern forming. Okay, so negative of -3 minus 0, which will give us 3. And I hope by now you can see a pattern forming. This will be 4, 5, 6. Okay, let's begin the next column. Substituting -2 here, so negative 2 minus 3, that's 2, take away 3, gives us -1. So substituting this in, negative of -2 minus 2, that will give us 0. And moving along to this one now, negative of -2 minus 1, that will give us 2. I hope you can see a pattern forming with this column and even a pattern with the entire thing here. Okay, so the next one, let's do one more and then I'll complete the pattern. So -2, so negative of -2 minus 0 is going to be, oops, sorry, I stopped up there, that should be 1. This one should have been 2. And by now, I hope you can see the next one's going to be 3, 4, and 5. I hope you can see a pattern forming along this diagonal where all of these will actually be 0. So let's test this. Negative of -1, substituting this, minus 1. That actually does indeed give us 0. And I hope from this you can see the pattern completing for the entire table. This will be 1, 2, 3, 4. This would be -1, -2. I hope you can see the pattern for the remainder of this table to be something like this, where we have gradients of zeros along this diagonal, and the remainders will increase by 1 the further out we go from 0. So now sketching this, what this indicates is along the diagonals of -3 and 3, -2 and 2, -1 and 1, and so on. So this diagonal, so starting here, starting from here, we'd have a 0 gradient, and it would be the same gradient along this diagonal. So let's draw that in first. So something like this. Let's do 2 at a time now. I hope you can see the pattern forming from this. We can you can fast forward really, because I think you get the idea for this. And we sketch the remainder in. So I hope you can see that below 0, the gradients are increasing by 1. So gradient of 1, 2, 3, 4, 5, and 6. I'm going to sketch that just by showing and sketching in a gradient of 1, like this, and then duplicating it and increasing the steepness ever so slightly as we keep moving down. Now from this you can see what the slope field can look like. Now remember, you can do this without a table of sines, but it just makes the task a lot easier. If you would like to try this without doing the table of sines to begin with, so just going straight into sketching it without using this, you can go right ahead, do that. All this does is just makes the task ever so slightly easier. Okay, so the last gradient here in our table is our steepest one of 6. Whoops. Now I hope you can see that the pattern is the same. So this set of gradients is found here. So fortunately for me, I can copy all of this and just copy it down below, and then take the same copy again with one less. So I'll copy just these and copy it again. So taking this, copy it underneath, and so on. Oops. And that there's the lower half of this directional field. So this lower bit here is represented here. And now I hope you can see as well that above is the exact same thing, but it's mirrored. Okay, so this would be -1, which would go this way. The next one above it would be -2, oops, which I will illustrate by just moving it slightly more, and so on. So I'm just going to keep duplicating this. You can fast forward this part, and I think you get the idea moving forward. And at the end of this video, I'll show you a computer-generated directional field for this. And there we have it. And now since we have these derivatives or these tangents, I can just copy and move it along like so. So copying. There we go. Copying once again. Oops. Oops, daisy. And one more. And that there is our directional field. Now remember, when we do this, it is not super accurate because it's not super accurate because we have values that are supposed to be drawn in at half steps. So these are all whole intervals, so 0, -1, -2, -3, -4. But now showing you a computer-generated directional field where every single half step is shown here. So this is what the directional field should look like. And this is what we got, which is not too far off. Okay, so yeah, I hope you could see that there was actually another pattern here where these are all 1. So it should have been the case. Whoops. No, I think we got everything there. There's that slope. There's that diagonal of zeros, by the way. I hope you can see them there. See, -1, 1. There's the horizontal gradients here, which is what we've shown here, horizontal gradients. Anyway, I hope that gave you an insight into sketching directional fields with more than one variable. Okay, so I hope to see you in the next video, and best of luck.